There we go. That would have been a quiet video for a while. So solving 3 by 3, we've already done the 2 by 2, and we found out you need to find an inverse, and then finding your inverse, then you can solve the equation. We're going to do the same idea with 3 by 3s, but we're going to do most of it with our calculator. But just a little bit of review. If you were solving for the determinant, you have the determinant formula for your 3 by 3 matrix, although we found out it's much easier just to rewrite the first two columns, and then 3 diagonals, the green ones here will be positive, the red ones would be negative, and then you could add them up to get your determinant. All right, so here's one for you to try. Already written the first three, or first columns again. Here are your positive ones, your negative ones, and you should have gotten negative 45 as your answer. So like I said before, finding the 3 by 3 inverse is complicated, so we're going to use our graphing calculator. That's what this GDC just says is for calculator. And if we find out that our determinant is equal to 0, then there's no inverse. So if you had calculated your determinant to equal 0, there'd be no inverse. So in this one that we did here before, the fact that the determinant was negative 45, this means that there is an inverse that exists for that. Yes? Well, because, is there a mistake? One, yeah. But what I did is I multiplied all of these in the red, and I added them all up, which makes 53, and I made the whole thing negative. You could make each individual one negative if you wanted to, but I just did it in the end, put them together, and then subtracted them after. That'll work out the same as if you'd made this negative 16, negative 1, and plus 8. You'd still get negative 53 there. Okay. So here's another one with our determinant. We're told that the inverse does not exist. And this is how you could take a question like this and make it a non-calculator question. I've rewritten the first two columns again, so we can find our determinant by multiplying through the diagonals. And if the inverse does not exist, then we have to make our determinant equal to 0. And then solving for that. If x happened to have been negative 14 over 3, then that inverse wouldn't have existed. Again, the same thing here for the red ones. I put them together and then subtracted them all at once. So what I'll get you to do is I'll get you to put both A and B into your calculators. So take out your graphing calculators, put A and B both into your calculators, and then use your calculator to find A inverse. So the first thing you want to find is, can you get those fractions to show up on your calculator? So in order to solve for P, The only way that you can get rid of this A is by multiplying by an A inverse. And if you multiply by A inverse in the front of the equation on the left side, you have to multiply by A inverse on the front of the equation on the other side. That will get P all by itself to equal A inverse times B. And typing that into your calculator, you should have got 1, 3, 1, 0, negative 1, 2, negative 2, 1, 0. So just like solving systems of equations with 2 by 2s, you can do the same thing with 3 by 3s. You set up your first matrix A as all of the coefficients of your equation. So it's important that you set things up. You set things up so that you always got x, then y, then z, x, then y, then z, x, then y, then z equals a number, so that we have our coefficients matrix in the right order, because that's going to be important. That way it fits with x, y, and z. That's your variable matrix, is equal to all those constants, 3, 2, and 8, your constant matrix. But unlike before where we could solve these by hand using matrices, we saw how complicated it was the other day to find an inverse of a 3 by 3, so we will use our calculators for these ones and solve this with our calculator. And scroll down so you can, at least before you start B, feel like you're doing a good job. If you were able to get 4, 1, negative 1 for A. All right, so there's the answer for B, and there is some practice questions on that handout that I gave you.